today's video, we are going to create experiment 5. So we will start a new project which is named experiment 5. So click next. Then the microcontroller we use is PIC16F18875. Then next. Then we will click the compiler which is the ECE8, and then we will name this project as experiment 5. There. So we will click finish and able to create the project. So now as we can see, there are several folders appear under experiment 5. So now we will proceed to our MCC, which is this icon. So we'll just click this icon to open our MPLAB Code Configurator or MCC. So it's still loading. So we will wait for a while, and then here it is. So for this experiment, uh, we will click save. Then yes. So we will try again since it doesn't appear, or maybe it crashes. So now there is our MCC window. So first, we will add our peripherals. Since this experiment covers to analog to digital input. So we will go to peripherals and we'll scroll, and we can see that there is ADCC. So we will click this panel and then click the plus sign to add ADCC to our project resources tab. So there, we already added our uh, ADCC on our project resources. So now we will proceed to our pin manager grid view, and then we will set our package to the pdip pdip40, since that is the current package we use in our experiments. So for this type of experiment, in our pin manager, we will set uh, port A0 as our analog input, which is here. We will click here in the A and X, which serves to set the analog input. And as we can see, uh, port A0 is in pin 2. So we will set for this experiment for our output, which is here in GPIO, which is the port A4. So port A4, click here, and now we can see it is in pin 6. So now we set our input and output pins. We will go to our pin module tab here. So now we will rename this uh, pin pins for our program to make programming the controller easier. So for our LED, which is here, we will rename it as D2 underscore LED. And for our uh, analog input, we will name it as put underscore A0 since we will use a potentiometer to uh, demonstrate the analog input in our controller. So, since we rename our uh, pins or we rename the pins designated to the input and output pin, we will proceed in setting those. So first, in LED, for our output pin, we will uncheck the analog since we will demonstrating analog to digital input or analog to digital input. So, and for our potentiometer, we will check the analog box and the WPU or weak pull up enable to set our potentiometer. Oh, sorry, it's unchecked. So we'll just only check the analog tab since it is an analog input. So now we will proceed to our system module. So as we can see, this is the system module. So our oscillator should be set in high frequency internal oscillator, which is this one. Then our internal clock should be in 4 megahertz and its clock divider should be at 4. So, and we will make sure that the low voltage programming enabled is checked. So as we can see, uh, our setting required uh, is already uh, is already set. So now we can proceed to our to the settings of the ADCC, which is here. So now this is the settings under the ADCC. So first, we will select our clock source, which is the which is here, which is frequency oscillator AD clock or ADC conversion clock source. So we should select uh, the box or this tab since there are two options. We will select this one. So for the clock, it should be frequency over 2. Then in this side, so we will make sure that the result adjustment is set to right. So this will produce a 10-bit ADC result and when it comes to positive reference, we should set it in VDD since VDD receives the positive 5 volts and the negative references is the VSS since it it is always set to the ground or negative 5 volts when uh, configuring our circuit. So now as we can see, uh, everything is set. So we will click the generate button. So now, as of now, it's still generating the button. It's generating the configuration rather. And now, as we can see, the generation is complete. So we will proceed. So we will close this tab first, and we can proceed to our main.c, which is under in the source files. So as we can see, it is blank. So we will apply our code here. So first, we will initialize the ADCC. So we will type ADCC initialize. Or we can check uh, in our MCC generated files under adcc.c, which is here. So as we can see, it means that the ADCC is initializing, or it will initialize the ADCC of the controller. So now proceeding to our code. So we will set a threshold in able to create in able to turn on our LED. In this uh, experiment, we will set the threshold to 512. So it means that if it is less than 512 bits, uh, the LED will set high. If anything goes above 512, it the LED will turn off. So by doing that, we will create an if else statement. So if uh, ADCC underscore get single conversion underscore port is 0. So if ADCC gets single conversion, which is detected in the channel in the pin 2, which is the port renamed as port A underscore A0 is less than 512, D2 LED will set high. And if it goes the value beyond 512, D2 LED will set low. So that is the code required for this experiment. So as we can see, the first thing the code will do is to initialize the ADCC and then detects the value of the potentiometer that is being set by using the function of getSingleConversion, and the parameters, which is the name of the pin, which is the port is 0, is less than 512, the LED will set high. If it's greater or equal to 512, the LED will set low or turn off. So our code is complete, we will click this hammer icon or the build main project. So as we can see, it's already compiling, and we can see the build is successful, which means it is ready to be uploaded in our IC. The program is being uploaded. So as we can see, uh, the VDD is connected to positive 5 volts, and the VSS, which is the black wire, is connected to the ground. Uh, the blue wire is connected to the output pin, which is pin 6, and to the LED, which is represents the output in series with the resistor, and the other the anode of the LED is connected to the ground. In terms of the potentiometer, uh, the first end is connected to 5 volts, which is represented by this red wire, and the third pin of the potentiometer is connected to the ground, while the yellow wire, which represents our signal wire, is connected to the pin 2, or the input pin of the IC. So as we can see, if we turn the potentiometer to the right, the LED light up. So as we go further, so this is the potentiometer, the value of the potentiometer, which is less than 512. So I think since I cannot turn the knob, so this is 0, the LED turned on. If we turn it to the right, as we turn it to the right, the LED turns off. So if we turn it further, the LED will still turn off, since the values of the potentiometer, when it is converted, it ranges from the value of 0 to 1023. So since if we turn it to the right, based on the code, is less than 512, so by turning it to the right, we're decreasing the value of the potentiometer, which turn on our LED. And if we turn it to the left, we increasing the value, which make the LED turned off, or uh, increasing it greater than 512. Uh, Hope you like this video, and see you again next time.